Hello friends, continuing with the topic of modulation in the chapter of communication systems. Today we come to the sixth part of communication systems. In this part we are going to study about frequency modulation and phase modulation. Previously we have studied about amplitude modulation in the first phase. Now in the second phase we will study about frequency modulation, and in the third phase we will study about phase modulation. First we take up frequency modulation. First part, that is a part of it, is definition. Let us define frequency modulation: the process by virtue of which modulating signal is superimposed over carrier wave and frequency of the carrier is varied in accordance with the instantaneous amplitude of modulating signal, keeping amplitude and phase of the carrier constant, is defined as frequency modulation. I repeat, the process by virtue of which modulating signal is superimposed over carrier wave and frequency of the carrier is varied in accordance with the instantaneous amplitude of the modulating signal, keeping amplitude and phase of the carrier constant, is defined as frequency modulation. Now look at this diagram. Here is the modulating signal, that is modulating wave, given by the expression EMT is equal to EM max sine omega mt. And here is the carrier wave, given by the expression ECT is equal to EC sine omega CT. The two waves are superimposed over each other here. This is the carrier wave and this is the modulating wave. According to the instantaneous amplitude of modulating wave, the frequency of the carrier is varied, and this is frequency modulation. So here is the frequency modulated wave. You can see here the frequency is high, this is low frequency region, and this is high frequency region, again this is low frequency region, and so on. The frequency of the carrier is varied in accordance with the instantaneous amplitude of modulating wave, keeping amplitude and phase of the carrier constant. Okay. Now B, mathematical expression of modulated wave. Now how we derive mathematical expression of modulated wave? Let us see. Let EMT is equal to EM max sine omega mt be the modulating signal superimposed over carrier wave ECT is equal to EC max sine omega CT plus phi. Where phi is the phase of the carrier wave. Now here is the modulating wave and this is the carrier wave. Now here the two waves are superimposed over each other. This is the carrier wave and this is the modulating wave. Then the amplitude of modulated wave at any instant of time, according to definition, can be expressed as E mod t is equal to EC max sine omega c plus kf EM max sine omega mt plus phi, where kf is constant of proportionality for frequency modulation. Here is the frequency modulated wave, where frequency of the carrier is varied in accordance with the instantaneous amplitude of modulated wave. Okay. Now C part, frequency deviation. How much frequency deviation takes place? The instantaneous frequency of modulated wave can be expressed as omega I is equal to omega c plus kf EM max sine omega mt. Now since omega is equal to 2 pi f, therefore we can express this expression as 2 pi Fi is equal to 2 pi Fc plus Kf EMT. Dividing by 2 pi on both sides of this equation, we get Fi is equal to Fc plus Kf EMT by 2 pi. This equation shows that frequency shift in frequency modulated wave is equal to KFEM by 2 pi. Because Fc is the carrier frequency, so frequency shift would be KFEMT by 2 pi. Thus, maximum frequency in modulated wave is Fmax is equal to Fc plus KFEMT by 2 pi. And minimum frequency is Fmin is equal to Fc minus KFEMT by 2 pi. Thus, frequency deviation in FM wave, say delta, is equal to KFEMT by 2 pi, or it is equal to Fmax minus Fc, or it is equal to Fc minus Fmin. So this expression shows that frequency deviation is directly proportional to instantaneous amplitude of modulating signal. D. Modulation index. Let us define modulation index in frequency modulation. The ratio of frequency deviation and modulating frequency is defined as modulation index of frequency modulated wave. I repeat, the ratio of frequency deviation and modulating frequency is defined as modulation index of frequency modulated wave, and mathematically expressed as MF is equal to frequency deviation divided by modulating frequency, that is delta by Fm, and it is equal to KFEM by 2 pi divided by Fm. Finally, modulation index MF is equal to KFEM by 2 pi divided by Fm. From this expression, we say this modulation index is directly proportional to amplitude of modulating signal and inversely proportional to frequency of modulating signal. Thus, modulation index is directly proportional to amplitude of modulating signal and inversely proportional to frequency of modulating signal. E. Advantages of FM over AM. Number 1, no power is wasted in transmission, completely efficient. Second, it is noise free. Third, stereo transmission is possible because of wide channel spacing, because channel spacing in FM transmission is 40 kilohertz. Now we come to third type of modulation in analog communication system, that is phase modulation. Now let us define phase modulation. Definition: the process by virtue of which modulating signal is superimposed over carrier wave and phase of the carrier is varied in accordance with the instantaneous amplitude of modulating signal, keeping amplitude and frequency of the carrier constant, is defined as phase modulation. I repeat, the process by virtue of which modulating signal is superimposed over carrier wave and phase of the carrier is varied in accordance with the instantaneous amplitude of the modulating signal, keeping amplitude and frequency of the carrier constant. Now look at this diagram. This is the modulating signal or modulating wave given by the expression EMT is equal to EMX sin omega mt. This is the carrier wave which is given by the expression ECT is equal to EC max sin omega CT. Here the two are superimposed over each other. So this is carrier wave and this is modulating wave. Now this is the phase modulated wave. Now here you can see there are two types of changes that we can observe. One is the change in frequency and the other is the change in phase here. So phase modulation finally is frequency modulation. Okay, when we carry out phase change, it results into finally frequency modulation. Okay. Now B, mathematical expression of phase modulated wave. Let EMT is equal to EMX sin omega MT be the modulating signal which is superimposed over carrier wave ECT is equal to EC max sin omega CT plus phi, where phi is the phase of the carrier. Here the two are superimposed over each other. This is the carrier wave and this is the modulating wave. Then the amplitude of modulated wave at any instant of time according to definition can be expressed as E mod T is equal to EC max sin omega CT plus within bracket phi plus Kp Em max sin omega MT, because it is a phase which is varied in accordance with the instantaneous amplitude of the modulating signal, where Kp is constant of proportionality for phase modulation. Now phase deviation. Phase deviation is equal to Kp Em max sin omega Mt. That is Kp Emt. Okay. Now from this expression of phase deviation which is equal to Kp into Emt, now consider the expression of phase deviation which is equal to Kp Emt, which shows that phase deviation is directly proportional to the instantaneous amplitude of the modulating signal. Okay. Now D, modulation index for phase modulation, which is MP. It is equal to phase deviation, which is equal to Kp Emt. Kp Emt. Thus, modulation index for phase modulation is MP equal to Kp Emt. Now E, frequency deviation. The finally phase modulation results in frequency modulation. To calculate frequency deviation, let us consider instantaneous phase of modulated signal, that is phi t is equal to omega ct plus phi plus Kp Em max sin omega Mt. Now differentiating it, we get d phi t by dt, which is equal to ddt of omega ct plus phi plus Kp Em max sin omega Mt. Or we can write d phi by dt is equal to ddt of omega ct plus ddt of phi plus ddt of Kp Em max sin omega Mt. Or we can write omega I is equal to omega c plus 0 plus Kp Em max cos omega Mt into omega m. Or we can write omega I is equal to omega c plus Kp Em max omega m cos omega Mt. Now since omega is equal to 2 pi f, so replacing omega by 2 pi f, we have here 2 pi fi is equal to 2 pi fc plus Kp Em max 2 pi fm cos omega Mt. Now cancelling 2 pi on both sides, we get Fi is equal to Fc plus Kp Em max Fm cos omega Mt, or Fi is equal to Fc plus Kp Em Fm, where Em is equal to Em max cos omega Mt. This equation reveals that frequency shift is equal to Kp Em Fm, where F max is equal to Fc plus Kp Em Fm and F min is equal to Fc minus Kp Em Fm. Now here, if we look at frequency Frequency deviation is number 1 directly proportional to instantaneous amplitude of modulating signal, and second also to frequency of modulating signal. Now if you look at the frequency deviation in frequency modulated wave, now if you compare frequency deviation with frequency modulated wave, their frequency deviation was directly proportional to instantaneous amplitude of modulating signal. Here first part is same, that is the frequency deviation is directly proportional to instantaneous amplitude of modulating signal, but in the second part it differs. Frequency deviation is directly proportional to frequency of modulating signal. So this is the difference between phase modulation and frequency modulation so far as frequency deviation is concerned. Assignment 15 continues. Question number 23. Differentiate between frequency modulation and phase modulation. Question number 24. Differentiate between modulation index and frequency deviation of FM and PM waves. Thank you so much. Next time we'll take up pulse modulation. Till then, goodbye and good luck to you.